Hi, this is Kevin Trainer, and welcome to part one of my tutorial for the coding assignment for Severance Chapter 14. And the this is the chapter where we're creating our own custom Python class. And if you haven't already listened to part zero of the tutorial, I'd advise that you do that. It's pretty lengthy, but in that part, I introduce this cheat sheet document, which is one that you're going to be able to use to create custom Python classes of the kind of data holder variety that are very popular. So I explain the cheat sheet in terms of a demonstration class that I created and that we use back in the homework for the chapter Zell 3rd edition, chapter 11. Okay, so go watch that if you haven't watched that yet, and then come on back. So, what are we doing in this part of the tutorial? Well, in part one, we're going to get ready for exercise one. And in this part, what we're going to do is to create a custom class given the requirements of the exercise. Now, the one that I'm going to do for practice is going to be different than the one that you're going to do for your assignment. Okay. Um, I want to point out here that you don't have to type this one in. Okay. You don't have to type this one in because I provided this to you as part of your starter files. Okay, so part of your starter files, if you look at the, if you download the zip files for revised starter files for Severance Chapter 14, and you expand it, you're going to see this the practice tutorial for Severance 14, and this has all the code that I create during all the parts of the tutorial. And sure, if you'd like to code it in as you're watching the tutorial, fine. Uh, Otherwise, you can just open it up and follow along. Okay, I want to save you the time from having to type all this in. And then when you're doing your own code for the exercises, you can use the code here as a kind of a reference point for how to do these things the right way. In some of the programs, you may want to copy and change rather than uh, create a whole new program yourself. Okay? And I've already got this one up. So if I look at my PyCharm and I look at the practice tutorial, it's already here. So what are the files that are in it? Well, we've got two data files. My basic states.py and my countries.py. These have the data that we're looking at. And if we open these up, I'm sorry, the data files are my basic, those are not the data files. It's very early here in the morning, so please excuse me. State area data.txt. That's the basic data file. These are states in the United States. They have so we have the name of the state. We have a float value for the population. And then we have a float value for the area in square miles. And these are separated by semicolons. Normally we separate by commas, and I think in your data that you're going to use, they're separated by commas, but I just wanted to show you what happened if we separated them by semicolons. Okay? There are two versions of this file. There's the real version, okay, state area data, and then there's a dirty version, dirty state area data.txt. What's the dirty version? Well, it's one where we've taken liberties to put invalid values in the input. So for instance, down here on line 9, we have a state where we forgot to put in the state name. Okay, when we go to read that, we're going to get the empty string. Okay, we have here up on line 1 a state where the population is negative. Okay, these are the kind of problems that you can find in dirty data that you're cleaning. And we're going to be creating two versions of our class here. And the first version is the basic version, and it's not going to do error checking. So it's going to allow us to read the dirty data and to create a dirty report. Okay, it's basic. Okay, and then later on in part 3, we're going to be creating an evolved version of the class, and we're going to introduce that kind of error checking when we create new instances of the class to make sure that we catch things like state names that are the empty string, or population values that are negative. And that we create a runtime error and we stop the program and we go back and clean our data. Okay, so those are the two versions of the data. Okay, we are going to create in this part of the tutorial, we're going to create the basic version of our custom class, and it's going to go into a file called mybasicstates.py, and let me open that. Okay, that's what we're creating in this tutorial. And then later on, we're going to be creating the rest of this, the rest of these data, the rest of these files in the rest of this tutorial. So again, you don't have to type in any of this. It's all in the starter files. And I recommend that you probably just follow the tutorial along in order to save time. Okay? Because this is a big assignment. Okay? All right, that's that. So let's go find the production version of the class. Of the real version of the tutorial project, which is called actual tutorial, and I already have that open too. Okay, and let me find the actual tutorial, and that's empty right now. Okay, so what do I want to do? Well, I want to create the I'm going to pause this and I'll be right back. Okay, we're back. So what we want to do is we want to create the basic version of the module, and again that's called mybasicstates.py. I'm going to do this the easy way. I'm just going to copy and paste the whole thing. Okay, we're going to paste it in. All right, and it's right there. And there it is. Okay. So I'm going to do something a little bit different this time. I'm going to, uh, and you might be able to do it with your code too. Normally, I have a bunch of monitors, and I'm able to park one version on one and another version on another. But I happen to be traveling today, so I've got my laptop here, and I want you to work with what I work with. So here's what we're going to do. We're just going to take all of the code in the module, okay, and we're just going to turn it into comments. We're going to toggle it into comments. And then instead of copying and pasting, we're going to toggle code out of a comment when we're going to turn it on. Okay, so let's look at our cheat sheet. What's the first thing we want to do? Well, we want to create a normal Python module file. Well, that's what we just did. We created one, and it's called my basic states. So we know that this holds the basic version of the class state. Okay, and what does a normal version typically have? Well, in my solutions, let me toggle off this code. It usually begins with a bunch of comments. Oh, these actually are comments. Sorry. I shouldn't have toggled them off. Let's go backwards. Yeah, there we are. A bunch of comments. We have the name of the file and then a description of what the file is. Okay, so those are already there. They're supposed to be comments. Okay, so we have a file and we've got the introductory comment. Now we wanted to, as item 2, we want to define any constants that are used in the class code itself or in the unit test. So let's go do that. And again, here are the constants. So we toggle them on. Okay, and you've already seen these if you've watched part 0. These are just constants for passed and failed that keep us from having to type the literal value over and over again. And they're here for our convenience. They're used in our unit test code. And this is a pretty standard feature. Okay, so we're just going to turn those on. All right, then what's the next thing that we do? Well, we're going to define the class with a header. So we have class name. In this case, we're going to have information about a state. So we're going to call the class state. Okay, and let's toggle those couple lines on. Okay, maybe I can make this code just a little bigger for you. Yeah, maybe something like that. Okay, maybe just a hair bigger. Okay, class state. So you can see that we have that. Notice that it has the colon. Okay, let's go back to the cheat sheet. 4, it defined a constructor. Okay, so we're going to have a def for a method. A constructor is a particular method, and it's called dunder init. And in there, we want to set the value for each instance variable that's coming into the constructor. And we want to make sure that we use cost int, float, string, etc. to control the values of the instance variables. So let's go turn all that on. Okay, so here it is. Here's the constructor. Pretty straightforward stuff. And here's the code. So now we have a constructor. And we have a def. A method is just a function that's associated with a class. Okay, that's why we're defining it with the def. And the name of it is dunder init. And every method has a reference to self, which is a reference to the instance that we're on. Okay, because the class is kind of a template, and each time we construct a class, the class is like a cookie cutter, and every time we construct a class, we punch a new cookie out of the cookie dough with the pattern that's in the class. And the initial values that we're passing in are the state name, the land area in square miles, the water area in square miles. Okay, and then what do we do with them? Well, we define each of the instance variable fields. So we assign a value to self.stateName. Now that says we're going to have an instance of variable called state name. So every instance is going to have its own state name. And then what do we do on the right side? Well, we get the value that we're passing into the formal parameter state name. And either to convert it or is simply as good documentation. If we're expecting a string value, then we call the string function in order to force it to a string. And so that users of the class, when they come to look at it, say, oh, I see, name is supposed to be a string. Land area in square miles is supposed to be a float. Water area in square miles is supposed to be a float. That's all we do. Okay, so what can we do now? Well, now we're going to jump ahead. Okay, we're going to jump ahead because later on at the very bottom of the cheat sheet, we say, how are we going to do the unit testing? Well, we're going to do it a little bit at a time. So even though, so every time we create another method, like the constructor, it's a special kind of method, well then we're going to create a unit test case for it. Now, where do the unit test cases go? Well, when you get down to number 10 here, it says place all of your unit testing code in the main method. It's a convention that we use in our course, but professional programmers use the same kind of unit testing approach in the code, but they use a unit testing framework, which is really beyond the scope of our course. So we're going to want to create a main. So let's go create a main. Okay, so down here we've got a main. Okay. And we want to create a test for the constructor. Okay. So the code that goes into main for the unit test, this is just all one big function. Okay. So each of the unit tests is kind of set off by one blank line. Within a function, we can have one blank line for a dramatic effect. So test case 1, the code is set off by one blank line for dramatic effect, and there it is. Okay, so we print that we're testing the constructor, and then as we typically do for these kind of things, the first thing that we do is we figure out what the test values are going to be for the instance variables. So it's going to be Alaska. It's got 570,000 square miles. That's the expected land area. And what's the expected water area? Well, 94,000 square miles. and we've got 2 decimal places. Okay? So then when we call the constructor, again, unit tests are client code. Okay, so we create an instance and we put the reference in the variable S1. And so we use the name of the class and then we pass in the initial values. So their expected state name, expected land area in square miles, expected water area in square miles. Okay. So at this point, we have our expected values. We have created the instance. Now we just want to go through and see if we pass the test. So if we have a series of things that we want to test, like we want to make sure that the 3 instance values are correct, well then here's what we're going to do. We're going to assume that it passed. We're going to say a result equal passed. And then we're going to test if we have an error on the name, an error on the land area in square miles, or an and on the water area, an error on the water area in square miles. And if we do, we're going to turn the result to failed. The last thing we do is we're going to print the result. Okay, so it's either going to print passed, which we hope, or failed. Okay, so how do we access the value of the instance variable? Well, again, the Pythonic way is you don't call any getters and setters in your explicit code. You simply use the name that points to the object, in this case S1, dot, and then the name of the instance variable, state name. So you actually examine the field itself. That's the Pythonic way to do it. So we want to know if the state name instance variable is the one that we expected, or that the land area in square miles instance variable is what we expected, or that the water area in square miles is what we expected. And if they are, then it's going to be passed. If not, it's going to come back as a failed. So let's give this a test. Let's run my basic states. And I'm not seeing what I expect, so I'm going to pause. Oh, I don't even have to pause. Why isn't it running our test? Well, I forgot to turn on one thing. Okay, at the very bottom. Okay, after all the unit test code, we need to turn on the code that invokes the unit test code only if this is being tested as a module all by itself. And there it is. Okay, if it's being tested as a module all by itself, then run the main. Okay, so let's give that a run now. And now we can see the output. Test case number 1, test the constructor, it passed. So there's a little bit of inspection that goes on in this kind of testing, but in a unit testing framework, it will look at all the test cases and it will tell us how many passed, how many failed. It'll do it in a real fancy way. Here we have to do a little inspection. We have to look for passed after every test. Okay, but we don't have to remember what proper values are, so this is a big help. Okay, so we got that far. So we tested the constructor, it passed. So now we're ready to go down to the next thing. That's number 5. Define the string method by creating the dunder stir. And then we're going to do the same thing for the repr method by creating dunder repr. And let's go look at these one at a time. Okay, so let's look at the string method. Okay, And let's turn that on. And this actually follows, it follows a convention, okay? And the convention is that uh, the string representation is going to be what looks like the code, the client code that would create an instance with these values. So we put out the name of the class and a paren, and then we put in the value of the state name. We surround it with single quotes, and we put out a comma, and then we print out the land area in square miles. Here we're going to format it to 2 decimal places, okay, because that's one of the requirements that we have for the class. So we print out the land area in square miles. We print out the water area in square miles, and then we close the paren. Okay. So this is what this looks like, and I just want to show you down here, if instead of test case 2, we just said, well, let's go to test case 2. All right. Let's find test case 2. This is where we test this string method. Okay, and I'm just going to cheat a bit so you can see how this works. Okay, so we construct the same we construct an instance using the same variable name S1 with the same initial values. That's good. What's happened if we just printed S1? Print string of S1. What does that look like? The string of that object. Okay, well, let's run a test again. Okay. And we can see here, let's make this a little bigger. That here's a string representation of it. So it says I want to create a state object, and the initial values are Alaska, and then this for the land area in square miles, and then this for the water area in square miles. So this is a really nice convention that Python programmers do for the string representation of their object. Okay, well, that's great. Now, in certain situations, so okay, well, let's take that one out. Okay, so let's take that out because that isn't the real test code. That would be testing by inspection. But the real more automated version is this. Okay, so now we're going to, I'm sorry, we're going to compare this to the expected value. All right, so let's bring in the rest of that unit testing code here. All right, and here it is. So we again we construct it, and then we said that the actual value is just the string of S1, and then we compare the actual to the expected, and it has we see if it passed or failed. Now let's give that a test, see if that runs. Let's run that one. And it turns out that it passed. Okay. Well, why did it pass? Well, because we put in the string that we were expecting into the expected string value. Okay. So, and then we fetched the actual string value and we compared them. Well, how do we know what this is going to be? Well, here's what I usually do. I usually cheat. Okay. So when I'm testing either the string method or later the repr, okay, I usually, the first time that I do the unit test, I have the expected string value equal to, well, I'm sorry, I don't actually do that. So let me back up. I just take this automated part of the test, okay, and I don't implement that yet, and I just I test it by inspection. So I say print string of S1, okay, and then I run it. So let's run the unit tests again. And what I get is this. So if I make this a little bigger, you can see it. So so what I do the first time that I test the string method is I test it by inspection. So I go, okay, it's supposed to be Alaska. All right, that checks out. It's supposed to be 570,000 and change. Inspect that. Yeah, that checks out. Okay, then the water area is supposed to be 94,000 and change. Okay, I inspected that. That works out. So once I've done that, then I can take this string and use it for the expected value. Okay, this works with automated test frameworks and generally our style of testing, which is not by inspection but by programmatic comparison. What we do is we get rid of that cheater that we use to create that value that I just copied, and then we write the rest of the test case code. Okay, in the test case code, we have an expected string value, which of course I don't want to calculate by hand. Okay, so what do? Well, the first time that I run the test for this, well then if in fact I don't put anything in the expected string value, the next time it's going to fail. You see, it failed. But I put a cheater line in and I get the actual value. I inspect it, and as soon as I do that, then I just plug it in here. Okay, and you can see that this has double quotes around the outside because we have single quotes on the inside. Okay, so once we do that, so we test it once by inspection, and then we copy the expected value that we got by writing a cheater line of code, and we put it in there. And from then on, you should be able to run it, and you don't have to test it by inspection. You can see here, the more programmatic version of the test has passed. Okay, so we have added the string method, okay, and we've tested it. Okay, so what's the next thing? So we're going to do the repr, okay. Now, it turns out that the repr is really helpful if in fact in your testing you want to display values and you want to display a list of your objects. If you don't implement the repr, then the string representation you're going to get for the objects isn't going to be the pretty one that we just saw. Okay, so you need, if you're going to do something that isn't even that complex, you need to implement both a string and a repr. There's our last um, part of our tutorial coming up now. Okay, let's shrink that. And then, so we're going to define the repr. Okay, so let's just go back to this code that we created here. And let's put in the repr method. And the repr method is very simple. It just calls the string. That's all it does, okay? Because uh, um, uh, both of them are to create a string representation. And the approach that we took to formatting the string representation of the object instance in string, it's the same one that people use for repr. So what we do is we just we return the value by calling the dunderStir method on this object, self.dunderStir . Okay? So, and this is important. You don't want to copy this code because you only want to maintain it in one place. Okay? So, the way to do this is to have the repr call the stir. Okay, so that's what we have. So it turns out that we've added that code. Let's go down and find the unit test 3. Okay, it turns out that we can really clone unit test 2 to create unit test 3. And that's how I did this. I just simply copied it and gave it a different title. Okay, but the code was exactly the same. All right, and I save this and I run it, and we've got test case 3 tests the repr method, and it passed as well. And not surprisingly, because we used the same testing code as we did for the string method. And how did we implement it? Well, we called the string method. So we would expect to get the same result. So, are we done? Well, we're almost done for this part 1. But we've got another couple things to do, okay? We need to, some of the values that we want to get from the data holder class can be calculated from the instance variables. And it's considered a good practice to not store them explicitly. Because if you store them explicitly, you have, one is you take up the space, but two, you have the problem that you could store contradictory values. So we're not going to store calculatable values explicitly in instance of variables, but we are going to provide a method to have the class calculate them for us. So what's the version of this that we're going to do in our case? Well, we want to calculate the total area in square miles. Well, it's really the sum of the land area in square miles and the water area in square miles. But we want to add this. This is a kind of a convenience method that does this in a reliable way that it can be used throughout our client code. Okay? So, again, this is, in some sense, it's a data value, but it's being implemented with a method because we're doing the calculation. It's behavior. Okay, so what we do is we return the sum of the land area in square miles, self.land area in square miles, plus the water area in square miles. And that's that. It's that simple. Okay, so how do we unit test that? Let's go down and look at the unit test for that. That's the last of the unit tests, for. So again, we're going to construct the same instance. Okay, and now a lot of people think, well, why do you construct this over and over again? Well, because in unit testing frameworks, each of these unit tests are kind of implemented inside of a method of their own, and they have to be independent of each other. So this is a good habit for when you're using a real unit testing framework later in life. So again, we have this standard code to set the expected values, and then we construct it. Okay. Notice that we add one expected value, which is the expected total area, which is actually the sum of these. Okay, I calculated it and we put it in here. And so now we're going to assume that we passed. Okay. And now here's what we're going to do. When you're working with floats, the comparisons are a little trickier, okay? Comparing floats to each other can sometimes, you might have a little artifact, a rounding artifact that will give you a slightly different value. Doesn't happen often with addition and subtraction like this, but this is the way we compare float values. We calculate the difference between the actual, which we do by calling the method, and the expected. Now we expect this to be very close to zero, and then what we call that the delta, the difference between what we're expecting and what we actually got back. Okay, and then we usually compare that to a very small value. I usually compare it to 1/100th of the precision that we're using. So if we're keeping 2 decimal places, okay, then I test that we're not different by more than 1 in 4 decimal places. So that's a 10,000th. Okay. So if we say the absolute value of the difference between the actual and the expected is more than 1/10,000th, then it failed. And I've got a print in here to just show what the value is when it failed. That was sort of a debugging feature that, well, we could take that out. I probably, in my production version of this, want to take out that print. Okay, that creates a chatty test. It failed. Otherwise, we just want to print result, which we're hoping is going to be passed. So let's do that. Let's run a test one more time. And we passed it. Okay. So we're done, but let's go back to the cheat sheet and make sure that we think we're done. Okay, we've just done number 7. So let's look at number 8. Consider adding any further methods to provide convenience for the class user or that implement advanced Python class features taught in more advanced Python courses. Well, this is a pretty simple class. I can't think of any other features I want. You might think of some. But I don't want to provide any of these advanced features. A typical advanced feature that we don't cover in this course is how to provide a natural sort order for instances of the class. Okay, we don't learn how to implement that. Okay, that's considered an intermediate skill. Okay, so uh, we consider 8 and you say, no, we don't want any of those. And number 9, we say if and only if we want to add special getter setter code to do error checking on the initial values, we'll then add that code. Well, we don't do that until we get to part 3 and we do this evolved version, okay? It's the kind of version that I want to teach you to do, but I'm teaching you to do it in 2 steps. So here in exercise 1, we don't want to do 9, okay? 10 says where the unit test goes. 11 says that you need this code at the end in order to make sure you only run the unit test code when it's being run as a module by itself and not when the module is being imported. And then after that, we just had the unit testing hints that we already covered. So we have here, we're done with the basic version of the state class. Okay, my basic states. And we passed all 4 of the unit tests. So we're done. So what I would recommend to you to do is to go from here, go to your assignment instructions and go and look at them. They have a part that corresponds to tutorial 0, which I hope you've already played. And then they have a part that corresponds to this tutorial 1. It's exercise 1. And this would be a good time to do exercise 1 while it's all fresh in your mind. And I'll see you back in tutorial 2. Bye-bye.